Once upon a time, I lived in an old flat. Only joking. I used to receive a lot of strange phone calls. Hello, can I order 2 large pizza, please? Sorry, got wrong number. I'd always reply like this, which is really, really annoying. You probably already guessed why. That's the answer. Look, how close to each other these 2 telephone numbers. Every digit is the same apart from one place. In order to precisely define how similar or how different between 2 strings, we have this formal definition. It is called Hamming distance. It says we compare any 2 code words and simply count how many numbers that differ from each other. In this case, we only have one place, so the Hamming distance is 1. Next, we further define Hamming distance over a set of code words. It is called the minimum distance of code C. It's defined as, in C, we look at all possible pairs and work out their distance, then find the smallest one. Let me give you a quick example. Suppose we have a C defined as a basic binary string of length of 2. Okay, that's all possible binary strings for length of 2. That's all possible pairs, and the shortest distance is 1. Therefore, the minimum distance of set C is 1. Let's have a look at more examples. First one is a base case we already talked about. The second one is extended from first one. As you can see, parity checking bit added in, if you're familiar with that. The minimum distance of this set is 2. Third one, based from C1, we simply triple all the binary bits. 1 will be 3, 1, 0 will be 3, 0. Okay, so the minimum distance for this set is 3. Now is the exciting part. We're going to explain relation between the minimum distance and the capability of error correction. So here is our theorem. It says if you have a minimum distance of s plus 1, you should be able to detect up to s errors. For example, if you have a minimum distance of 2, then you should be able to detect 1 error. If a telephone company makes sure his telephone numbers have a distance of at least 2, then I won't receive a wrong number from a pizza shop, simply because if you dial 1 wrong number, you will end it into an invalid phone number, because at least the 2 valid number should have a distance of 2. Our next theorem says if the minimum distance of set C is 2s plus 1, we'll be able to correct up to s errors. Be careful, here we're talking about correct, not just detect errors. Imagine we have 2 legal code words here, x and y. If you're guaranteed the minimum distance, at least double s, add plus 1 and have another s here, which is 2s plus 1. So we'll be able to identify anything goes wrong. Say if you landed here, on this side, we can bring you back to correct value, which is x. But if you landed here, and we will be able to bring you back to y. It provides error is no more than s. Let's summarize what we just talked about now. We introduced matrix, measuring distance between 2 code words. We also introduced 2 theorems. Generally speaking, the bigger distance, the better error correcting ability. Thank you very much for watching.